I will explain a little bit about the circuit. So in this side, this is the input for the high voltage DC, while on the right side in here is the for the output of the sine wave voltage. And then in this circuit there is 4 switch. In this case I use IGBT, so 2 in here and then 2 in here. For this 2 is for the high frequency switching around 24 kilohertz, and then for the other 2 is for the fundamental frequency switching around 50 hertz. And then for each IGBT I use an individual driver, and then this driver have an individual isolated DC-DC converter for powering the gate of the IGBT. So because this combination, I can isolate the high voltage DC bus with the lower voltage DC bus. And then for the lower voltage DC bus, I use 12 volt for the powering the isolated DC-DC converter. And then there is a step down in here, buck converter, to convert from 12 to 5 to powering the microcontroller, and then the current sensor, and then the voltage sensing. The relay and then the resistor in here for the inrush current limited side. And then last is the LC filter in here, the inductor and then the capacitor. For the inductor I use 400 microhenry, and then for the capacitor is 3.3 microfarad. This combination will be result in around 4 kilohertz cutoff frequency. But because this because I think the inductor value is too small, so the ripple current will be very high, around 9 amps peak to peak without load. So why I didn't increase the number of turn to increase the value of inductor, because if I increase, it will be get saturated. So I need to change the inductor and then increase to the value around 2 millihenry to smalling the ripple current, and then lower the cutoff frequency to get a more better result on the sine wave. Last, and then for the code of the microcontroller, I put on my GitHub, and then you can use it. And then the schematic and the PCB design, I upload it to the GitHub. The picture only. So you can try and then let me know. Thank you. Okay, right now we will test the circuit using a resistor. It's about 90 ohms or 80 ohms, I forgot. So the calculation will be around 600 watt or 700 watt of power load. And then there is a current probe and then voltage probe for the oscilloscope, so we can see the output waveform like that. And then for the low voltage, the power is supplied by this power supply, 12 volt. And then for the high voltage, because this is only the inverter without the step up, so it's supplied from this power supply about 370 volt. And then the circuit is right now working without voltage feedback, so it's still open loop. I still working on the voltage feedback for the circuit. And then previously I applied some current protection, but it's too sensitive. So because the previous current sensor, the ratio is smaller than I want, so I replace it right now, but I haven't calibrated it yet, so I turn off the protection. And then we can just start by turning on the low voltage. And then right now the relay already on, and then we can see the waveform from here. So actually it have like a soft start, so it's not directly full voltage, it's gradually increased. And then we can see the measurement, the frequency, the RMS voltage and the RMS current. So based on the calculation, it's about like 500, 600 I think more than 600 watt. And then yeah, this is the waveform. You can look closely. So yeah, I think I can conclude that the circuit is work perfectly. I assume that it can be work at like more than 1 kilowatt. But the input capacitor I think is too small, so the current ripple on the DC input may be a little bit too high, and then make the input capacitor a little bit warm. But I think it's okay. And then the efficiency, I guess, is not very good, because right now I using IGBT, not a MOSFET. So the IGBT, the rise time and the falling time, the delay is very high. So that's why if we look closely again on the waveform, if we zoom in, it have like a small flat section in here. This is because the delay, the turn on requirement of the IGBT is very high than compared to the duty cycle. So we can say that the delay eating the duty cycle. So maybe this is like below 3%. It's already on zero. So like, so maybe next time I can change the IGBT with MOSFET, and then increase the frequency switching. So yeah, that's all for this video. Thank you.